Hello. Let's take a look at question 6, and this is taken from Kang Secondary School, end of year paper 2018, paper 1. Given that 9 to the power of n plus 2 minus 3 to the power of 2n plus 2 over 2 to the power of 5 is equals to 2 to the power of a multiplied by 3 to the power of b, find integers a and b in terms of n. Next, hence or otherwise solve the equation, whatever expression that you have just now, equals to 1 out of 4. Okay, this is a 7-mark question. As you can see, it's rather lengthy. So if you look at the original equation that has been given to you, it's rather complicated. Let's see whether we could simplify that. All right. So looking at the left-hand side, you realize that the base of one of the digits is 9, right? The other is 3. 9 is equals to the square of 3. So what we could do is we could manipulate this first term. And we could put it down as 3 to the power of 2, okay, bracket, n plus 2, minus 3 to the power of 2n plus 2, out of 2 to the power of 5 equals to. Next, let's expand out the first term. So I'm still working on this part of the equation. After expansion, I should get 3 to the power of 2n plus 4. Okay, now, what else can I do? Well, realize that something seems to be appearing in both the terms in the numerator. Right? I see 3 and then I see a 2n in the power for both terms. Now, is there a way that we could possibly extract that out? Well, one of the laws of indices mentioned that if you have 3 to the power of 2n plus 4, we could split it up into 3 to the power of 2n multiplied by 3 to the power of 4. Right? And if I'm not wrong, that is the converse of the first law of indices. And the second term can be split up into 3 to the power of 2n multiplied by 3 to the power of 2. Putting that together, denominator remains the same and right-hand side remains the same. Okay, what's next? You realize that in the numerator, we now have a common term that we can factorize out. Rather, we can factorize something that is common from both terms. Okay, now this is one term. There's a 3 to the power of 2n. This is the second term. There's also 3 to the power of 2n. So I am going to extract out 3 to the power of 2n from the numerator. Okay, what am I left with? First term, I'm left with 3 to the power of 4. And second term, I'm left with 3 to the power of 2. Next step, I realized that out of all the answers that I have, right, I can actually work this out into a certain answer, right? A certain value itself. So 3 to the power of 4 is actually 81. 3 to the power of 2 is 9. Okay, divided by 2 to the power of 5, which is 32, if I'm not wrong. Yes, 32. Okay, so that would be equals to 2 power A, 3 power B. Okay, so 3 to the power of 2n. Okay. This portion over here, when I continue to work it out, I will end up with 9 to the power of 4. Sorry, 9 over 4. Okay, which is 2 to the power of A, 3 to the power of B. How else can I manipulate this? Well, I have a base 3 here. I have a base 3 here. It looks like I don't need to do anything to this value, 3 to the power of 2n yet. But There's something about the 9 and the 4 that I can continue to manipulate such that I move down towards a base 2 and a base 3. Recall that 9 is equals to 3 to the power of 2 and 4 is equals to 2 to the power of 2. So this is where we can replace 9 out of 4 as a certain fraction to the power of 2. Okay, so we could write it this way. What's next? Next, I'm going to combine the terms where they have the common base, and that is 3 to the power of 2n together with 3 to the power of 2. So I will have something like 3 to the power of 2n times 3 to the power of 2 over 2 to the power of 2 equals to 2 power a, 3 power b. Everything now is in terms of a base 2 or 3. Combining the numerator of the left-hand side, I would have 3 to the power of 2n plus 2. Denominator, 2 to the power of 2. If I were to bring it up to the numerator, I would multiply it by 2 to the power of negative 2. Because when we bring up a negative index, we bring up a negative index, let me repeat. When we bring up a positive index, it becomes negative. So I will end up with 2 to the power of a, 3 to the power of b. All right. So I think we can do a comparison now. If you were to compare base 2, we would say that a equals to negative 2. So this is the answer. Okay, and how about b? The powers of base 3 would say that b is equals to 2n plus 2. So this is the second part. So this is the first 5 marks. This is for A, part 1. How about part 2? Part 2 is a lot easier, only if you can solve for part 1. So hence or otherwise, solve the equation. And you realize that this equation is exactly what is given at the in the first sentence. And after working out to give the final line, okay, we would actually say that this 3 to the power of 2n plus 2 times 2 to the power minus 2 is exactly what the left-hand side of the equation is all about. Essentially, we can say that 3 to the power of 2n plus 2 times 2 to the power of minus 2 equals to 1/4. All right. Well, we could simplify the left-hand side because 2 to the power of minus 2 is equals to 1/4. From here, we can simplify both sides by dividing it by a quarter. So we left with 1. And we could also conclude that 1 can be represented as a base 3. 1 is 3 to the power of 0. Again, this is another fact that we learned in EMATS indices. So therefore, we could finally say that since both left and right-hand side have base 3, we can compare the powers. So 2n plus 2 must be 0, and hence n equals to negative 1. So this is the solution for the question.